So again, this is inspired from when I took the test this morning while eating Crunchy Raisin Bran. You a fan of Crunchy Raisin Bran? My sixth grader wanted Cocoa Puffs. I said, I will only fix you a bowl of Cocoa Puffs if you will say I'm cuckoo for Cocoa Puffs. He's like, Dad. But he said it, so I should have recorded it. I don't know if he'd have said it then or not. No, I didn't write this down. 24-ish multiple choice. 5-ish. I mean, I'm within one or two here. I do remember that there were 29 questions. Free response. It is no calculator, but most of the calculations are pretty simple. So the pre-cal teachers were talking yesterday, like, wait a minute, are we okay with no calculator? Like, well, let's work the test and see. I had to use keep it, change it, flip it 4 times, I think, and they were all pretty easy. So it wasn't like, there was one yesterday where we had like 13 over 27, times 81 over 4. Like, no, it was easier than that. So I don't feel bad about saying it's no calculator. Most of the computation stuff is pretty straightforward. There wasn't any of that. There wasn't any of like on the worksheets. There was some that was like 120 times 27. Like, nope, there wasn't any that bad. It's sort of rigged where a bunch of stuff reduces. Like one time you're multiplying by 100. Several times things reduce, and so you'll be okay without a calculator. Okay, let's talk. I don't have this in order right now. Let's talk about the formulas you need to know. And then I'll talk about which ones are given and which ones you need to memorize, know. So there's term formulas, there's sum formulas, and then there's an infinite sum formula. For arithmetic and geometric. So let's see, the term formula for arithmetic. Actually, let's do term and geometric, or arithmetic and geometric at the same time, because to me they follow a similar pattern. Because they both start with the first term. What do you do to get to the next term in an arithmetic sequence? You add.
Add or add a
D might be negative, but we'll say add, because D might be negative, but we'll say you add. What about to get to the next term in a geometric? Well, times, because that's the difference between arithmetic and geometric. What are you adding in arithmetic? What do we call that thing? Call that D, the common difference. And we do that n minus 1 times. In geometric, we're multiplying by r, the common ratio. And if we want to multiply n minus 1 times, it is an exponent. Sum formula. These two will both be given. Let's see. N a1 plus an all over 2. The trick, maybe it's a trick, I don't know. A1 is the first term, an is the last term. So if it starts at 3, you got to be careful, then that's really A3, but it's the first term. A1 means the first term. Whether you plug in 1 or not depends on the problem.
So if it was like the sigma, and then it's like n equals 3, and then 12 at the top, it'd be A3 and then A12.
Right. And how many terms would that be if you went from 3 to 12?
9.
Not 9.
3.
It'd be 10. I know, sometimes it's like, but yes, it'd be 10. Sum for geometric is A1, 1 minus r to the n, over 1 minus r. And what you have to be careful about here is signs. So especially if r is negative, because then you have a negative something raised to a power. Does it stay negative? Does it go positive? 1 minus a negative becomes positive. So be careful with the negatives on that one. Infinite sum of an arithmetic, that doesn't make sense, because if you keep adding 4 or subtracting 6, like it's going to go to positive or negative infinity. So that doesn't make sense. But for a geometric, it's that formula, but only if
it's less than 1.
Less than 1. The terms get smaller is the easy way to say it. The terms only get smaller if r is less than 1. Absolute value, because r could be negative.
And then if r was greater than 1?
If r is greater than 1,
you just say
it's greater.
That's a good question. If r is greater than or equal to 1, what's the fancy term? Diverge.
that's all you gotta say.
Yeah.
I think it's bigger.
Or no sum, or infinity, or depending on how it's kind of worded. Oh, what's given? So how should we mark that? Should we highlight the ones that are given, or highlight the ones that are not given? Highlight the ones that are given.
Yeah.
Okay. Both those sum ones are given. And this term one is given.
How come
Why? Because arithmetic is kind of easy.
And my thing is arithmetic is kind of easy.
Yeah.
You can figure that one out.
but why is it
Just
because
So
because of
this one we want you to memorize.
Yeah.
Although I'll tell you this, and you may want to find it first. I forget which question it is, but there's a multiple choice question that basically says, what's the formula? So, if you can get close and recognize, where the pieces go, then once you hit that question, hey, box that one, and then you've got that one.
Is it going to be like, what's
that makes sense.
Divergent of infinite sum? Is that what it's going to be like? Or how's the question going to be worded?
Like, there's one question that just says, what's the formula for the sum of an infinite geometric series? And that's one of your answer choices.
So it could be either, well, I guess that's...
And the others, I don't know what the others are. Maybe one of those.
But you don't know what it is.
Switch
because
those.
It's not right. That's the right one.
So I'm saying, as long as you recognize it as the right one, so you have to have it memorized mostly, but also if you could just recognize it because of the multiple choice test, if you can find it among 4 options, then you'd have that one.
Got it.
Like you said, arithmetic, usually you can kind of figure out. Geometric, you can usually figure out, but we give it to you. So there's what you have and what you need to know. So we talked about converge, diverge. Now I just want to give some sort of examples that are kind of like ones on the test. Examine, comment on this sequence.
Wait, but this may be like that weird thing.
So that's a weird one.
It'd be
2,
the
2,
one
2, 2, 2.
So it would be where your
R is 1.
n would be
Geometric R1.
Okay, so we have one person claiming that it's geometric with R equal 1.
Bingo.
I will buy that.
oh
Would someone like to make another claim on what type of sequence that is?
yeah. Well, if it was
Arithmetic
n
0.
would equal 2.
Yeah.
Arithmetic with D equals 0.
Yeah.
So that's kind of a weird one. It could be either one. And you could write the equation either way even. And it would actually reduce to the same thing. In fact, actually let's do that. If we write the equation thinking that it's geometric, a sub n equals a1, I'm using the formula that's right up there, times r, which is 1, to the n minus 1.
So like on a test,
But what's 1 to the n minus 1 always going to equal?
1.
Well, 1 to anything is going to be 1. 2 times 1 is going to be 2. Well, that matches. All my terms are 2.
Yeah.
Let's start with thinking that it's arithmetic. So first term is 2 plus common difference is 0 times n minus 1. That's always going to be 2. That's kind of a weird way to look at an odd sequence. It could be geometric, it could be arithmetic.
So you said that this one was like similar to one of the tests, like, so how like it be like question?
I think I've given enough hints on the one that's like that on the test.
Okay.
I don't fault you for asking more, but we'll leave it at that.
Alright,
That's probably the easiest one in the entire test.
I guess.
Well, I mean, it's not hard, it's just we hadn't seen one that was quite like that, where you could be either one.
So would we have to find the formula or like the rate or like the RD?
Maybe, yes, all the above.
Long story short, that's the answer.
Don't mess up and skip that one. Jokes on you, can't.
Alright, now we'll just do a couple of example problems that are test inspired.
That's the next one.
Test
63.
inspired.
Test inspired.
3 over 2. Oh wait.
So what's what's going on here is the first question.
Dividing by 2.
Dividing by
Or
2.
dividing by 1/2, which makes it. Or
But we don't like dividing by 2.
multiplying by 1/2, which makes the fractions look better.
So r is 1/2. Find the sum. So can I find the sum? Does this have a sum?
Yeah.
Yeah.
Even though it's an infinite?
Yeah.
Okay, so yes, because r is less than 1. So the formula is what we, a1 over 1 minus r,
Negative 6.
negative 6.
1 minus 1 half.
Yeah,
Negative 6 over 1 half.
so negative 6 over 1/2. So there's an example of keep it, change it, flip it, but not a hard keep it, change it, flip it, I hope. Negative 6 times 2 over 1, negative 12. That's it. I can pull off the hard ones, but you guys think that one's an easy one. That's good.
Apparently is too. Yes.
Um,
It's because that's so much calculus point, that's how it just works.
find r.
Is that 3.7?
I'm going to give you 4 different ones to find r on,
Is that 3 times that?
because I hope we can find r without writing a bunch of different terms. That's 3 times 7 to the n. So if you know what you're looking for, this is an easy question. So take a minute and figure out what r is for each of those.
So
Again, if you get stuck on one, you can write out the first few terms and figure out r that way. But man, it just goes a lot quicker when you get to the point where you can recognize what r is.
Man, I just need to drink a crap ton of caffeine while I test it. Because I know everything.
How about converge or diverge for each of those?
For each of them.
converge.
Wait, first one, converge or diverge?
Wait a second, it has to be a certain one.
Why diverge?
Is it bigger than
Greater
zero?
than 1.
Bigger than 1.
Oh shoot.
Second example, converge or diverge?
Converge.
Converge.
That's
Negative 11 sevenths.
diverge.
It's a fraction.
Doesn't matter.
Right. It's bigger than 1, so it diverges. Some people, they get in their head that all fractions are less than 1. Like, no, look at the fraction. That's going to make those numbers get bigger.
Converge, isn't it?
So diverge. What about the next one?
Converge.
Converge. Decimal, but smaller than 1.
It's almost a diverge.
That's right. It's close. Might take a while to converge because it's not getting smaller quick, but it is getting smaller.
Technically, then number 9.
Oh good god. At the 1/3.
Even if it's a negative number, it's still, like, if it's greater than 1, it's going to be a negative.
It's the absolute value of it. So the absolute value of negative 11 sevenths is 11 sevenths. That's bigger than 1. So the negative makes it like change signs, but it's changing signs and getting bigger, so it's oscillating crazy, and it will never amount to anything. How about just an algebra problem? Why don't you solve that for A1? I'll give you a minute to do it. So I'm going to do it, I'll do it a couple ways. First thing I do is 1 minus 4/7. That is 3/7. Now here is where we might part paths or take different roads here. So Ty, what did you do from here? Because I liked what you said to do. Okay, we've got a denominator, we don't like it, let's multiply both sides by 3/7. And then, yeah, it looks ugly, but 3/7 over 3/7, that goes away. And then on the other side, 21 times 3/7. Well, I could multiply and then divide, but it would sure be easier to simplify first. And get 9. Is that good? Does anybody want to see it a different way?
No.
Because there is a different way to do it, and you may have done it a different way.
This one seemed easier.
Here's the only other way to do it. Not the only other way. How do I do A1 divided by 3/7? So forget about getting rid of it. How do I fix that? I could keep it, change it, flip it. And then in order to get rid of the fraction, I would multiply by 3/7. So you end up doing the same thing either way. But that's another keep it, change it, flip it problem. All right, last one, and then I'll take questions. Find k such that
Wait a second. Hold on.
Okay, find k such that the infinite sum is equal to 8. So use the infinite sum formula. Start with that. Plug in the pieces that you know. And see if you can find what k is. N equals 0, sorry. So there's a couple of weird things about that one. But I would start by writing the sum formula, an infinite sum formula. Plug in the pieces that you know, and see if you can figure out what k is. I'll leave you alone because I'd like you to try it. Well then, magically that's a lot like that algebra problem we just did. But there was a little more setup to it. We know the sum. Figure out what the first term is by plugging in the bottom number. So is it A1 or A0? It's the first term. That's what we're concerned with, the first term. R is 1/3, and now it's an algebra issue from here. An issue. You've got issues.
Oh, I do have issues.
So I would multiply both sides by 2/3, kind of like we did a minute ago. And k equals 16/3. All right, that's the notes that I took while taking the test this morning of things that I wanted to make sure that you saw before the test.
Can we look at the test this morning?